Good news for you today. We'll be working on our last set of identities, which are called the sum and the difference identities. So essentially, these identities, we're going to be taking two angles and adding or subtracting them together and being able to get the exact value of the sin, cos, tan of that sum or that difference of the two angles. So take a moment, pause the video, record these 6 identities in your notes. And again, you don't have to memorize these. They'll be given to you. You just need to know when to use them and how to use them. We'll pick a couple angles to use. Let's go with angle A. We know the sine of angle A, or the opposite over the hypotenuse, is 12/13. Now that being positive means we could either be in quadrant 1 or 2. Let's go with quadrant 1 for angle A. And now we need another angle to either add or subtract to angle A, so angle B. And this, I'm going to give us the cos of angle B, or the adjacent over the hypotenuse, will be 4/5. Now with the cos being positive, we could either be in quadrant 1 or 4. Let's go quadrant 4 for angle B. And let's take these two angles and find the sine of angle A and B added together. So that means we're going to be using the formula sin A cos B plus cos A sin B. Now, with the given information in this problem, we already know some of these. We already know sin of A is 12/13. And we also know that cos of B is 4/5. Now, as for the other part of this formula, the cos A and the sin B, this is where we're going to need to draw our triangles. So, angle A is in quadrant 1 and has a sin of 12/13. So, to figure out cos of angle A, I'm going to need the adjacent side, which when you do Pythagorean theorem comes out to be 5. So the cos of angle A is going to be 5/13. And now the sin of angle B, we only know the cos, so we're going to have to go and draw a triangle for this in quadrant 4. Cos is 4/5. So that means Pythagorean theorem would tell us this opposite side is 3. But remember, this is going to be -3 because it's going down into the 4th quadrant. So the sin of angle B is -3/5. And once we have those ratios plugged in, now it's real easy. We just use our fraction rules and arithmetic. So multiplying these first two fractions, the sine times the cos, will be 48/65. And then multiplying the second two fractions will make -15/65. And isn't this convenient? They already have common denominators, so when we go to add them together, we're going to have 65 in the denominator, and 48 plus -15 is 33. And so the sine of angle A and B added together is 33/65. Next, let's go ahead and do cos of A plus B. So we're going to need our identity that goes cos A, cos B, minus sine A, sine B. And again, we know all the information we need. The problem gave us sine A, which was 12/13. And the problem gave us cos B, which was 4/5. And now we're going to use our triangles to come up with the cos A and the sin B. The cos of A is the adjacent over the hypotenuse on the first triangle, which is the 5/13. And on the second triangle for angle B, the sine is the -3/5. And now again, we just multiply the fractions. 20/65, -36/65, And now when I add the opposite, this is actually going to be 20 plus 36, 56 over 65. And since I already know the sine of a plus b and the cos of a plus b, technically if I wanted tan of a plus b, I can just take these two answers for sine and cos and divide them and get 33 over 56. I will check that using the formula though. Notice that the tan formula, all it uses is the tan ratio. So we're going to have to look back at our triangles to get the tan of A and the tan of B. So tan of A, opposite over adjacent on the first triangle, will be 12/5. Opposite over adjacent on the second triangle for triangle B will be -3 over 4. And then that's what I'm going to need in my denominator is 12/5 for tan A and times -3/4 for tan B. So up here in the numerator I'm adding these two fractions, so I'm going to need common denominators. So let me make them into 20s. So this will be 48/20 plus -15/20. Down in the denominator, let's multiply those two fractions, which will be -36 over 20. In the denominator, this will be add the opposite, and 1 plus 36/20 will really be 20/20 plus 36/20. So we will have up in the top, 48 minus 15 will be 33/20, and in the denominator 56/20. Those two denominators of 20 can cancel each other out, and there's our 33/56 that I had just by doing sin of a plus b divided by cos of a plus b.